revisit the door problem, which is number 1 on your group work practice here. Right? You should have done number 1. Now, what I have here is a very similar scenario with only some slight changes. If you look here, and we'll talk through this, we'll figure out where these equations come from, but this system right here is what you should already have for number 1 in your group work packet. But there are some changes. So let's read through the scenario. A carpenter takes 6 hours to make an exterior wooden door and 4 hours to make an interior door. He takes 1 hour to paint each type of door. Each month, he allows a maximum of 96 hours for making doors and 20 hours for painting doors. Those first few sentences are all the same as the first time you did this problem. And that is where you get these two equations from, these two inequalities. Remember, that is where you're going to make your table, where you have the topic, x, y, and the total. And you are going to make equations for how long it takes to make the doors and how long it takes to paint the interior and exterior doors. Okay? So those two equations are from the first two sentences, or first 2 or 3 sentences up here. Okay? Now, the next sentence that we get to is a little bit different than what we started with last time. It says, because of the demand for the doors, the carpenter must make at least 4 exterior doors per week and at least 6 interior doors per week in order to stay up to date on orders. Right? So the carpenter can't just make them as slow as he wants, he needs to fulfill the orders. Then it says it finishes with the profit is $45 for an exterior door and $30 for an interior door. That is where you get this profit function right here. It says X is the exterior, so $45 for an exterior door, plus $30 for the interior door, which is Y. Now, with this system, this matched exactly the constraints that we were given the first time around. But something about this needs to be changed. We are going to cross off the constraints that are no longer needed for this problem and rewrite those. We get a hint of this in what's highlighted in green. Again, because of the demand, the carpenter must make at least 4 exterior doors. Well, at least 4 exterior doors means the exterior doors is X. You have to make greater than or equal to 4 exterior doors. That equation allows us to cross off X as greater than or equal to 0. Remember, we wrote that because we said we had to have a positive number of doors, whereas this guy that we just wrote means you have to have a minimum of 4 exterior doors created. Same thing with at least 6 interior doors. You need to write the equation Y is greater than or equal to 6, which replaces that other one. Now that I have these constraints, there's now 4 different equations, and 2 different ones, 2 of the same. You need to follow the process the same way. Your feasible region is going to look slightly different than the feasible region from what you did on your group work packet, but the process is the same. So let's make sure we know how to graph these lines. X is greater than or equal to 4 is going to be a vertical line at X equals 4 right here. Y greater than or equal to 6 is a horizontal line at Y equals 6. Now in order to graph the inequalities right here, you need to solve them for Y. I'm going to do that. I'm not going to talk through every step for solving here. I want you to pause the video, solve those 2 inequalities for Y yourself, and then come and check your work back on the video when you are done. Alright, now that we have solved both of those inequalities for Y, they're the 2 inequalities that are in yellow, you now need to plot those graphs on your grid. So the top one here, Y is less than or equal to 24 minus 3 over 2x. You're going to start at 24, and you're going to go down 3, right 2. Make sure as you're graphing these, we've talked about in class, that your lines are intersecting. If they're not intersecting, you probably made a mistake somewhere, but those are going to be the vertices of your feasible region. So there's our first constraint. Then we'll graph y is less than or equal to 20 minus x. So we'll start at 20, and this time our slope is down 1, right 1. Okay, so as we graph this one, let's see, back here. There is the 4 constraints graph. Now remember, you graphed 4 lines, which means that your feasible region should have 4 sides to it. And you can see right in here is the feasible region with 4 sides. Now we need to know the vertices of that feasible region, so I want you to darken in the points where those inequalities intersect. Those 4 points you're going to list in part C. Those are the coordinates of your feasible region. So the first point is down here at 4, 6. The next point happens at 12, 6. These are going to be different points, by the way, than what you did in your group work. This point up here is at 8, 12. And finally, the last point looks like it's at 4, 16. Now, at one of those vertices is where you're going to answer the question, how many doors? Great, sorry about that. So we are going to take each of those ordered pairs and put them into the profit function, which is up here, that you found the other day, to determine which one gives us the maximum profit. All right, so let me bring this down a little bit. So we had our profit function. Let me rewrite it here. The profit between the exterior and interior doors is $45 for an exterior door and $30 for an interior door. Remember, as you're working on this, that you take the profit of each ordered pair. So you put the 4, 6 in. The 4 is an x, the 6 is a y. And you put those in for x and y in your function. So you got 45 times 4 plus 6, plus 30 times 6. And you will calculate that to figure out that combination of 4 exterior doors and 6 interior doors gives you a profit of $360. All right, so I want you to pause the video. I want you to check the other 3 ordered pairs, and then we'll come back together and talk about the final answer. All right, so we look at our results here, and we see that we actually have the maximum of 720 that shows up 2 times. That's okay. We can have 2 combinations of doors that give us a maximum. So here, the way you would write your final answer is that this carpenter is going to make a max profit of $720 when he sells, for the first ordered pair, 12, 6. That would be 12 exterior and 6 interior doors. Or if he does the combination of 8 exterior and 12 interior doors. All right, so running through that problem, I just wanted to make sure you understood the new constraints, that sometimes you're not just going to make greater than or equal to 0 number of a product. Sometimes they give you a more specific constraint about the quantity needing to produce.